Okay, so this is a shot of a building in Fort St. John. It's it's the largest passive house projects in the West that is passive house rated, and this is something that we did a couple years ago, maybe. And it was an interesting project. Again, it's all about energy modeling. And we happened to do a fairly standard product here, but actually flipped the argon gas fill for krypton. So forgive me if you're not real window people, but I will try to hit that balance a little bit. So about Dexton. Dexton was founded in 2000 by my dad, Al Dueck. He's a real energetic guy who has a huge passion for high performance products. He's never wanted to kind of go the standard route, go with the easiest option. He's trying to push the envelope and make sure that we're offering something exciting and new. So this is our factory in Winnipeg. It's about 25,000 square feet. We've got 80 people on staff. And yeah, that's kind of a quick little highlight about us. So why would we talk about innovation? As I sort of touched on, it's been a part of our DNA from day one, even when we didn't have a whole lot of products or even systems to access necessarily. We were always trying to listen to what designers wanted, what the professionals in the building industry wanted, and be able to respond to it. So early on, curved tops. Fiberglass is not a bendable material because it's very tough and stiff, which is a great quality for windows. But when you try to curve it, it becomes a real challenge. So Prairie architects looking for a round window, this was a pretty big deal 20 years ago. Sun certified in the middle there, and net zero homes. There's a few really incredible builders that we've worked with over the years. I tried to focus a bit more on Manitoba related projects, but Sun Certified is one of those incredible, homegrown businesses that is really passionate about reducing our carbon footprint and is one of those companies that leads by doing. And so we've tried to work closely with them to make sure that the wall detail or the installation detail is what they need to support a thicker wall or whatever they're looking for that way. The real Al Dueck has joined us on camera. The right picture there, VIGs in Alaska. So I tried to mix in a little bit more crazy stuff just for sake of interest, but VIG means a vacuum insulated glass. And there's always talk and excitement about it because of the capability to get the R value or the insulative value of a window to be as high performing as it possibly can. So we've tried to be, as Al would say, on the leading edge and not the bleeding edge. And back then we were trying out a small scale project to see how they would perform, and they just weren't totally ready for commercial availability. Since then, I'm guessing we're starting to get closer. This is fast forwarding 20 years later now, but we were always willing to go out on a bit of a limb and see how far we could push that envelope. Sorry for the bad pun, maybe. Winnipeg School Division, one of the early adopters of fiberglass. Some context with a fiberglass frame is that it's not the oldest frame out there. It might be in the 30 to 40 year category now. But when it came to Manitoba and we were just launching our business, it was a lot lesser known. It was just generally known as something of interest for the light commercial or commercial market. Same kind of concept with that bottom middle in the multifamily kind of applications. And then listening to, all these professionals in the industry has been key for us. And as we understood the U value or R value requirements, so that's the thermal picture, but also the wind loading. You need your window to hold up to towers, if schools are supposed to be a safe place of shelter. So we have launched our own product line, which is called Fiberwall, and that was in direct response to everything that the community was looking for. And it's continued to be a huge part of our business, both now and in the future. So a big part of having innovative building materials available is being able to offer it at a good price point and something that people can justify. So whether it's that it pays back, or that instead of, we've seen as short as 7 or 8 years replacing what were new windows, you're trying to hit 20, 30 years of longevity. But with that, how do you stay competitive? And so automation has been something that's growing in our industry. It's actually incredible what's available to you, even as a medium-sized business. You don't necessarily have to be a huge multinational business to start doing these things. So the bottom picture is CNC that's drilling for casements and awning. So the crank, the lock, there's actually a lot of drilling and machining required. And then that top right picture is for cutting and drilling for frame assembly. The other thing I'd like to mention is that having the right team with us has made a huge difference, and they continue to grow with us day by day, and their skill set is incredible. Like some of these younger people's ability to build CNCs, to do the programming. I would have thought at one point that was a really specialized field, but it's becoming more and more accessible, which is a really good thing for us trying to do cutting edge buildings. I'm going to flash through some of these quicker, but swinging doors, again, the demand for super water penetration testing, something that would have been done at what's called a 330 pascals, trying to double that water penetration rating. This is a European locking system that not only just latches in multiple spots on a door, but once you throw the lever, it progressively sucks in that door against the frame. And so for air, water, and even like people will see frost creeping on their doors, these are incredible solutions that will start changing the game. Sliding door systems, it's amazing when you're working on a new product, how you think that you've designed it, you've done your drawings, you've sourced your parts, and then off you go. But the heart of continuous improvement is that you're never done. You're always going to be tweaking on different weather strippings. What's the best path for water drainage, et cetera, et cetera. So this is a 10-story building in Regina by Crozier-Kilgore. And actually following that cleanly into this, because building envelopes are getting more and more complex over time, the systems have to work really well together. As you add more insulation on the exterior, you want the window placed in the right spot. Rain screen principles are needing to come into the installation part as well. So window manufacturers are already designing rain screen systems right into the window itself. And rain screen means that you're expecting water to hit that building, but a bit further in somewhere, you've got that real concrete wall where you're not going to get water past it. And so you got this kind of ability to manage water like a lot of building systems nowadays in terms of the facades. So for the installation, certain provinces are starting to do this really well, and Crozier continues to be a real leader in this area. And so I think, again, coming to innovation, it's about working with those industry leading partners and, just always moving forward. Non-combustible applications. So for those of you who might not be familiar, on some of these taller buildings with glazing that goes floor to floor to floor, you don't want fires to be able to spread from one floor to the next. Historically, aluminum is a system that is going to find its place there, but the problem with aluminum is that it's very conductive, and so you don't get the insulative value that you're looking for. So very new in the market place, but something that we're working with to find progress. Low E glass, this is a new coating that has been released by Cardinal. In the broader scheme, though, I think we've tried to take a perspective of education, whether it's this low E or another. I think we've been trying to take the position that there's so many options when it comes to glazing. And if you know what you're trying to achieve, or you're working with an energy model, and I think this would resonate a lot with the sustainability folks, but properly working with an energy model will just make all the difference in achieving the right kind of building. Cooling loads are actually a bigger and bigger concern for us as the planet heats up. And so you don't want your air conditioning running overtime because you were trying to overly compensate for heat gain. So a little bit of context there. Okay, so this is getting a little bit into what's here now and what you might be able to see in the future. So kind of your scale of R values and how they climb up. I'm going to focus a little bit more on kind of these lesser known products right now. So after your triple pane options, there's something called thin glass out there. So this started with cell phones, the Gorilla Glass stuff, really, really thin pieces of glass that are super tough to break. And then it went to TV screens and huge screens in New York City. They were able to use this for, oh, thank you, Laura. Okay, I better speed up. Anyhow, so thin glass is converted into the ability to make quad pane glass. So it's kind of your next step in our value. Then you've got a multi-film product that's actually getting made in Edmonton, and then vacuum insulated sealed units. Vacuum insulated sealed units are not necessarily just one piece on one piece, but might need to be made into a sealed unit to really get that stellar performance. Glazing innovations. So after those first three, it's crazy. This stuff isn't that far out, and that's why it's kind of fun to talk about. So photovoltaic glass, I was chatting with a glass manufacturer, and he was saying that you know, there's definitely people out there that are making it. So photovoltaic is it absorbs energy and converts into electricity for your lighting or whatever. But the tricky thing is it just doesn't absorb a lot of energy because it's clear, whereas what you have on your rooftop is dark and can absorb a whole pile of energy. So the energy from the rooftop could convert 20%, whereas out of glass, it's 2 to 3%. So right now, as the technology stands, it's just not making a ton of energy, but again, it's something that's growing in the marketplace. And then this last one is kind of fun, these transparent aerogels. So MIT in Massachusetts has been working on this technology that's transparent, and they call it blue smoke. And it was used by NASA to insulate, and it's actually something that has a very real possibility of becoming an insulative material. And this is my last one, so some food for thought. You know, you talk about the life cycle of products and the embodied energy. So in my conversations with somebody, he was saying, you know, how far are you going to push the limit of just getting a specific window to a certain R value or thermal performance, but what are you spending to actually make the product? And so as he kind of colloquially said, using natural gas to convert rocks into glass, you know, we're still going to have to think about the whole life cycle of the product and where that stands. That's it.
A lot of what I'm going to just talk about here is on our website, which is Quik-Therm.com, Quik Therm.com. A little bit about Quik-Therm. We founded it here in Manitoba in 2010. And our kind of claim to fame in the industry is we're the little company that nobody's ever heard of. But over the last decade, we've conducted over 70 ASTM standard test procedures. And included in that are about 30 effective R value tests. It's called ASTM C1363. And what that test method is you're testing the complete assembly. So as the assembly would be designed to be installed on a building or a home, you test that exact assembly and it comes back and it tells you specifically what the effective R value of the assembly is in the temperature that you're testing it at. So when we did our testing, we did it all based on Canadian weather-like situations, Manitoba in particular. So we know how these walls perform. One of the other claims to fame with us is we are involved and have been utilized in the two largest passive house buildings in Canada, both of them in Vancouver. Now that's surpassed, I believe, in Toronto. And we've been, I guess you might say, the movers and the shakers in the industry in the passive house end of things have been attracted to our technology and have embraced it and have put it into a number of these buildings. Arguably, possibly, or potentially the most energy efficient building in Canada, passive house, is in Nanaimo. It's the Aboriginal Passive House Center, and it's got air change per hour of 0.2 air changes per hour, which is almost nothing, or approximately 10 times better than the average house. The issues with insulation are really simple. It's all about moisture. And there's thermal bridging that is caused through framing members, fasteners, air leakage moving from the warm side of the building in the winter here in Manitoba through to the cold side, coming in contact with cold objects. Condensation is formed, and the next thing you know, you've got all sorts of issues and mold and various other things. So what we've done is we've developed systems that allow the walls and roofs to dry and drain. So as opposed to typical flat insulation materials that you would see if you were at your Home Depot, your white foam, blue foam, pink foam, different types of products like that, our products typically, not all of them, but a lot of them have got grooves in them. They allow some air to move and dry. It allows some moisture to follow gravity and drain out of the buildings. And that's probably, not probably, the biggest issue with rigid foam installation is because it's flat, it can trap moisture and it's got nowhere to go. It can't dry to the inside, it can't dry to the outside, and thus it gets stuck in place. And if the same types of things continue to happen over a period of time, the walls potentially can rot right out. Again, really unfortunate you can't see the screens because you'd start to understand the science, but when it comes to the building envelope, heat moves from warm to cold. So in the wintertime, we've got heat always trying to get outside. In the summer, in our summers, which are basically, we'll say June, July, and August, the heat energy is trying to get inside. So heat always moves to cold. High moisture always moves to low moisture, and high pressure, which in the winter we're heating our buildings, we're creating pressure inside them, is always trying to get outside. And thus it's taking moisture and heat energy with it. We've designed systems, science-based systems, that allow the moisture to move through the system and go right through the insulation and or encompass or run into little air gaps where we're telling the moisture at this point in time, this is where we want the dew point to occur. And the dew point will typically occur in those places. Then as the temperature changes, it either turns to liquid water or vapor, and it dries and it drains. We have some new systems on the market, and when I call them new, they're not that new. They've been around for 3 or 4 years, where we actually incorporate the framing right into the insulation, or the furring is a better way of putting it. If we look at typical walls on buildings, we'll see metal strapping or furring, we'll see wood furring over top of the insulation, and that's there in place so that they can connect the cladding to it. We've designed systems that have it built right into it. So as opposed to, say, I'll use an example of, well, we've got to go onto the wall, the system, or the wall, and we got to put a house wrap And then we've got to put our insulation and we've got to tack that in place. And then on top of that, we've got to put furring and cladding and fasteners and whatever the case may be. We've got a couple of systems that go on in one simple application. They cost a lot less and they perform in some cases, in many cases, a lot better. Again, I would suggest if you're interested in what I've said here is to get on our website. And you'll see I really feel bad that I couldn't bring this up because it's there's some pretty neat stuff and intriguing and things that you have not seen before. But we've got a new system on the market and it's been installed on about a half a dozen really large projects here in Manitoba and northern Manitoba, where it's a 2-layer system of insulation with built-in furring. So the furring in the first layer connects to the framing of the building, and the furring in the second layer attaches to the first layer. So there is zero thermal bridging through the system. So there's no bridging through the fasteners. There's no bridging through the framing. In essence, it's virtually 100% thermal bridge free. It's got built-in draining and drying into it. And these systems that are double layers are typically buildings where the owner of the building is looking for super high performance. Government buildings, institutional buildings, most of them low-rise buildings, 6 stories and under. And what we're able to do with it is able to use a lot less insulation and gain a lot more performance than what is typically being done. We often see in some of these systems where we're involved in, where we're being comparative, where one building system envelope systems $300,000, and our system might come in at $200,000. It could be $100,000 savings. It could be a $50,000 savings. And a lot of that has to do with time and labor. We've also incorporated those designs with venting and perforation into a roof system. We call it the Matrix Composite Roofing Insulation System. It's been on the market a little over a year, attracted a lot of attention. We're working with arguably some of the largest roofing corporations, contracting corporations in North America with it. And we've done a number of jobs in the past 6 months, 9 months, and they've all been successful. And again, it does the same thing. Whenever there's moisture inside the system, it gives it an opportunity to either dry, the moisture to diffuse through the actual products, or hit the vents and drain outward or downward.
Ted, I got your presentation here. If there's a specific slide you want me to go to, I don't know if you can see it on your window.
Well, if you wanted to go back, could you go to, now, did you get this from Ryan or did you get this from me?
Ryan just sent it to me.
Then it won't be correct
because
I've revamped it. I revamped it. We'll try to go to the, let's go to the third last slide, please.
Right there.
Does it say 936 connect on the top?
You know what? I was on 936 connect just when you asked for it. So we're on that one now.
Okay, so they can see that. This will help a fair bit. This is a brand new technology. We've messed around with it, and that's the best way to describe it in small additions, some shops that have been built over the last couple of years, trying to come up with a system that would solve the problems that we're having with homes and also increase the energy efficiency of the building walls and homes and lower the cost. So what you see there with the 936 system is, unlike a conventional wall, which if we go from the inside, we've got drywall. This system has drywall. Then we have, in most cases, almost all cases here in Manitoba, they put a poly vapor barrier. This system has no poly vapor barrier. Then the cavity has got fiberglass or mineral wool insulation. This also has fiberglass or mineral wool insulation. But when we get to the outside, there is no sheathing. So when you look at a house going up, you'll typically see OSB or plywood sheathing on the outside of the wall. And then on top of that, you'll see a layer, usually white, of what's called a house wrap or a WRB, which is going over top of it to protect it from moisture. Our system, what we call 936, is the insulation panel on the outboard side. It's the furring that connects to the framing. As I said, there's no sheathing. There's no thermal bridging. It allows the wall to drain and dry to the outboard side. And it also covers the rim joist areas of houses. So if I'm a builder and I'm building a house, I'm typically going to spray foam the little cavities that are in my basement wall and the top part of my wall. That's about $10 a lineal foot, give or take, here in Manitoba. This system incorporates it all in one. So basically what we're able to do here is build the whole wall with fundamentally two components from an insulation standpoint. The exterior sheathing is insulation, furring. It's a vapor barrier or a vapor retardant. That's a better way to put it. And it also reflects radiant energy, and it eliminates a lot of the components that trap moisture. So we got excited about this again because the cost of lumber has gone through the roof. As we know, this system we're anticipating is about, for a builder to build it, is about 15 to 20% less expensive. And that's a bit of a guesstimate. And it'll perform 30+% better from an R value standard. So it will meet all of the new codes. It already, as a 2x4 system, meets the codes in Zone 8, which is Northern Manitoba. So before we bring it on the market, we were fortunate enough to apply for some funding with the province of Manitoba. And we took some of that funding, which we achieved, and we thank them very much for that. We put forth to do a bunch of stress tests, vapor barrier, air barrier tests at BTAC, which is Red River College, for those of you that may not know. So what we've done is we've constructed a 12x12 wall. You can see us being constructed, so it's fastened to the studs with a framing nailer, just as you would attach OSB. That's the middle picture. And then on the far right, there's the framing on the top side. And then as opposed to using, well, it's typically not foams there, but WRB or we'll call air barrier sealants, we're just using a sill gasket, which is going around the perimeter of the wall, and the pressure from the nailer seals the system to the framing. And that great big thing on the left-hand side is the chamber that it will be going in. So that window won't be there, that wall won't be there. Our wall will be replaced in that, and that'll be tested in about 10 days from now. So once we get the results from the testing, assuming it does all the things that we believe it'll do, then we'll be launching and bringing it out and putting it on the marketplace. And we've got, a number of builders that have some significant interest in it at this point in time. So we're all about innovation. In our view, and it's been our view since we got into it, and this is no disrespect to other insulation, but the insulation industry in general is really, really archaic. And we're hoping we can make a significant change here moving forward. So with that, I will end. I apologize. This is not my long suit, this technology stuff. I thought I had it all figured out. Ryan and I role played it, but it didn't work out. I'd like to thank you all for putting up with me and listening to what I had to say. And there's a lot more that you can see if you hop on our website at Quik-Therm.com.